Welcome to my session, Signal Correlation. My name is Hausenblas, and I work in the AWS Open Source Observability Service team. So let's jump right into it. What is the context? Context here is observability. And if you squint a little bit, then observability really is kind of applied data engineering. So what's the goal? We want to continuously generate and discover actionable insights based on signals, telemetry, from some system under observation. And the goal is to influence that system. So imagine some application running there, you get some system signals out of that, and either a human or a piece of software takes these signals and makes some decision based on that. So if we look at a monolith, then this is usually a rather straightforward thing. It's clear where to look, what to look at, and so on. But if we split that monolith apart and we're dealing with a microservice with various services that communicate over a network, then obviously there are a number of pros, feature velocity, dealing with polyglot systems in terms of data source, partial HA. But then there are also some downsides to it. Now you're dealing with a distributed system. There's more complexity, and most importantly for our conversation here, observability is not optional anymore. You need to have an observability strategy. So moving on to the four fundamental signal types that we're talking about here. Logs, I assume everyone is more or less familiar with. Those are timestamp textual signals capturing what is going on within a service and usually consumed by humans. Metrics are aggregates, and those can be from one service or across services, and they represent, for example, the health of a system or performance. Traces are distributed traces, are signals capturing cross-service execution along a request path. Get back to that in a moment. And last but not least, profiles that capture, again, what happens within a service in terms of resource usage, think CPU, memory, etc. Why do I mention all of that? If we look, for example, at traces, if you have a microservices set up and you have a request coming in the front end that calls out to other microservices, then one way to think about that is in this waterfall model where you see the overall request and then how much time the request spends in a certain service. This call front end calls out to A and B, further to C and D, and then somewhere to a data store, for example. You can see how long the request spends in each of those services or the data store. So getting back to these four fundamental signal types that I mentioned early on, you can imagine that these signal types each have part of the answer for a certain question. Remember initially when I said observability, we want to get insights, actionable insights for our system that, for example, is a microservices setup. So given one signal, the question is, how can we find relevant signals that are from a different type? So for example, you start out with a log line, you ask yourself, what are profiles around that? Or you start out with metrics and you want to see some traces. So let's have a look at some concrete examples of those transitions between the different signal types. For example, for metrics to traces, input might be a time series, for example, a dashboard, and you want to figure out one or more representative traces there that represent cross-service execution. Or from metrics to logs, input again a metrics time series, and then the output would be a log line or log lines from an impacted service. Traces to logs. If you have a distributed trace, one or more spans, that again representing this cross-service execution, the output would be, for example, log lines from one of those services that are contributing. So traces, input would be a log line, and for example, the output would be a trace of that service. And traces to profiles, input would be a trace with one or more spans, again representing this cross-service execution, and the output would be, for example, a profile from a service contributing to that span. So again, why do we need that correlation? Two reasons. In the context of distributed systems, it means there are many different services that work together to represent a request path, for example. It's not entirely clear what part contributes, for example, to a failure or slow, whatever. And it is the case that these four fundamental observability signals, logs, metrics, traces, distributed traces, and profiles, they cover each different aspects, but on their own, they can't answer all potential questions that we need to answer for those actionable insights that we seek to have for observability. So let's have a look at use cases for correlation. Imagine, for example, incident response. Imagine you're on call for a certain app that spans various services. You get paged, and there is an alert that contains a link to a metrics dashboard. From the dashboard, you can see there's increased error rate, 500 getting into the red zone. And you want to figure out what services along the request path contribute to the error you see, right? So you, for example, in this case, would use metrics traces correlation to get an insight into one of those services. Moving on to root cause analysis. After the fact, so once everything is more or less done, you want to figure out what actually caused it. And telemetry provides you with a lot of metadata, right? What region, what version of a certain library or service. And the question is, can you use these correlated data to figure out the root cause? So for example, is it a certain machine or machine type? Is it in a certain region, certain service, certain version of a service? Moving on to performance improvements. So let's imagine there is a ticket that says that a certain number of customers report a slow execution for a certain endpoint. So certain, they check out, for example. And the service graph that the distributed tracing provides you allows you to have a look at what services together handle this request path and to figure out what service to improve. You could, for example, use traces to profiles, because with profiles, you get all these CPU and memory information for a particular service. So you could, for example, figure out the impact of a new version of a service in terms of comparing these profiles, and you get to that from the traces. So far, we've mainly been talking about why correlation in the context of the distributed systems, microservices, and what the use cases are, so the motivation, if you will. Now let's have a closer look at how that actually could work. We could call it a stack, correlation stack. Effectively, there are three layers to it. The instrumentation layer, the backend, so that's where the different observability or telemetry signals are stored. And then the front end, that's where you actually get to see, for example, jump from metrics to traces. In this context, in terms of instrumentation, I'd like to point out OpenTelemetry. This is the standard for all kinds of observability signals. It is a cloud-native computing foundation project. After Kubernetes is the second biggest and most active one. It's essentially a set of specifications, a protocol called OTLP, an agent called the collector, and a number of libraries, SDKs, across 11 different languages. And if you look at how it works, you have essentially various data sources. So that's where the signals come out of. That might be some infrastructure, for example, an AWS API. It might be your application. And those sources send all kinds of signals to an agent, usually. In the agent, you have various pipelines, one dedicated to a signal type, and then you have the correlated telemetry data in various backends. Now, backends, you can imagine, this is where the connection to the context here comes into play. This is where you want to do that correlation and need support for that. So talking about various backends, you can have signal-specific ones. Think, for example, about Prometheus or metrics. Time series, usually a big challenge there. And in the context of ClickHouse, there is OpenTelemetry support. I provided here an example of the ClickHouse exporter that allows you to ingest logs and traces into ClickHouse. In this case, essentially, the configuration is so that the pipeline receives a log from a Fluent bit through the Fluent bit forwarder, and then batches it up, and then it exports or ingests these logs into ClickHouse. You see how that looks like. You can use ClickHouse to query that. And if you also would ingest traces, you could use ClickHouse in this context to do actual traces and logs correlation. If you're interested in trying that out, have a look at the exporter there in the OpenTelemetry project and try it out for yourself. So let's have a closer look at one concrete end-to-end example with metrics and traces. In this case, an application would send traces and metrics into a traces backend, in this case X-rays, and Prometheus for metrics, and then would use Grafana as the single pane of glass to actually perform the correlation. So you would have the front end, the presentation layer would be Grafana, the backends would be X-ray and Prometheus, and the instrumentation would be through OpenTelemetry. In the code, you would emit a so-called exemplar that allows you to embed a trace ID in the metrics. And that's the way how it looks like on the wire, if you wish. If you look at it as the Prometheus exposition format, then you would see the trace ID there embedded. And that is what actually then can be used in the front end in Grafana to perform that correlation. You see there at the bottom the exemplar. So you configure, you essentially tell Grafana what is the effective name of that. So trace ID, that's what we use there. And then you would be able to see that it's just a dot. You can essentially click on that and it takes you to the trace, for example, in our case, in X-ray. So that was one concrete end-to-end example. It's still relatively early days. If you think about all four signals, correlation of all of them. And there are a number of challenges on the road ahead. In terms of labels and attributes, inconsistent metadata, and sampling can be a challenge. And what I'd like to really call out here in terms of end-to-end support are backends. So this is really, motivation, I hope, for you if you're in that space. For example, you're trying to use ClickHouse as a backend for telemetry to, trying to improve that, to help further this observability correlation story. Okay, and I hope we have a few minutes left for Q&A. I think we should have some 4 minutes or so.
Yeah, thanks, Michael. If there are any questions, just use the Q&A icon on your Zoom interface, and you can ask your questions there. We still have a couple of minutes. If you have any questions,
perfect.
Thanks very much. I don't see any questions, Michael. If you want to wrap up for today, but thank you so much for joining us for OSA Con and for presenting. And for people who had questions on it before, of course, we will make the recordings available, in a few days, so people will be able to rewatch this presentation, and then if there's questions, we can follow up at that point as well. But thank you so much for today, Michael.
All right. Thank you. Have a good one.
Thank you.
Bye.